Welcome to Biostats for Evidence-Based Practice. This course, we are going to focus on the application of statistics in the healthcare field. So rather than really focusing on how to calculate statistics, I want this to be helpful for you to apply knowledge of biostatistics in your practice. So when you read a research article, I want you to be able to critically think about the results section, evaluate the research, evaluate the data that was collected, how it was analyzed, if that was appropriate, and so you can really look at the validity of a research study and decide whether it's applicable to apply to your practice. So I don't want you to worry about focusing on a lot of calculating and formulas, but we're going to much more focus on applying statistics. So this first lecture is going to give you just an overview of some information that you've probably learned in research classes in the past, and your readings in your textbook will also go over all of these. I listed some additional resources on Blackboard, so whatever you feel like you need more information on, make sure that you review those areas, but this whole lecture should be a review of information that you've already heard in your past education. So I'm going to give just lots of definitions, terms, make sure that we're all kind of on the same page at the starting point of this class. So data are collected in a raw form, and then statistics are how we add structure to that raw data. There's two kind of big types of statistics. One is descriptive. So if you want to be able to describe what your raw data is, one way would be just to list out a huge list of all the data you collected, which really isn't useful for most people. So descriptive statistics are a way to present, organize, summarize your data. It helps you recognize trends, looks at averages. And then the second type of statistics is inferential. And this is where raw data is put through statistical tests to come up with some sort of conclusion about a population. So inferential statistics allow for generalizations from a sample data to a larger group or population. So if you think about it, most researchers really aren't interested in just describing their sample, but they want to be able to generalize their findings to a larger group. And inferential statistics are what lets you do this. So in studies, you have variables. You probably remember in the past learning about independent and dependent variables. It's really important that you remember what these are, and that when you're reading an article, you're able to identify which is the independent and which is the dependent variable, because these are used in statistical tests. So you want to be really clear that you know which is which, so that you can identify if the right statistical test was used. I often think of the independent variable as your predictor variable and your dependent variable as your outcome variable. So let's see. Variables, let me give some examples. Let's see. Variables overall are characteristics that can be manipulated or observed, and they can take on a wide range of values, so they can vary, as opposed to a constant, which just stays the same. Let's think of some examples I can give you to identify the difference between independent and dependent variables. Let's say that you were reading a study where the researchers divided the subjects into two groups, and they gave some sort of educational intervention to one group, and they didn't give it to the other group, and then they looked at maybe skill level a month later. Your independent variable, or your predictor, would be whether they got the education session or not. And your dependent variable, which is also thought of as your outcome, would be how they performed on that skill test a month later. You could also have, let's say a researcher, for another example, was looking at gender differences in study habits. So in this kind of question, your predictor, or your independent variable, would be gender, male, female. And your dependent variable, or your outcome, would be study habits. So make sure that you can really, look at some different articles, make sure you understand what's the independent and dependent variable. This is going to come up in every module of this class, and in statistical tests, you often have to identify what's the independent and what's the dependent variable, and you would get different results if you mix them up. So make sure that if you look at a research question or hypothesis, you're able to distinguish between independent and dependent variables. All right, so if we are describing variables, I'm going to talk in this lecture about some different ways to describe variables. So variables could be described as either discrete or continuous. And this is a classification of variables. So discrete means that it can take on one value out of a limited number of options. So this could be something like number of kids. You could have 1 kid, 2 kids, 3 kids, on and on, but you can't have 3.41 kids. So the number of kids that you have is a discrete variable. Heart rate is another discrete variable. You could have 80 beats per minute, you could have 62 beats per minute, but you can't have 62.13 beats per minute. So heart rate is a discrete variable. And a subset of discrete variables is dichotomous. So this is a particular kind of discrete variable where there are only 2 possible values that a person could take on. So an example of a discrete dichotomous variable would be gender, male or female. So once again, there's only limited number of options, but in dichotomous, it's only 2 options. And discrete variables are in comparison to continuous variables. So continuous variables can take on any number within a range, and they're only limited by the precision of the measurement tool you're using to measure the variable. So let's say that we are looking at height. We might have a stadiometer that only has markings at the centimeter marks. So you might measure one person and they are 158 centimeters tall, and then another person is 159 centimeters tall. But height can actually even be more precise. So if you had a stadiometer that had 1/10 of a centimeter markings, you might see that one person actually was 158.1 centimeters, and another person was 158.2 centimeters. You could buy a stadiometer that's even more precise and that goes to the 100th centimeters. So height can take on a wide range of values depending on how precise your measurement tool is. This is another really important distinction to understand because there are some statistical tests that you can only run with discrete variables or only run with continuous variables. So you want to make sure you can identify when you're reading a study whether they're just talking about discrete or continuous variables. And then the last key concept that you want to understand is the level of measurement. So this kind of takes the discrete continuous a step further. And once again, there's statistical tests that can only be done with interval ratio level data and not with nominal. So you want to make sure that you can read an article and identify which of these 4 levels of measurement the data are. So nominal data are named categories. So these could be like yes or no, or race. Race is a good nominal data. Ordinal data are categorical data, but that are ordered or ranked. So they're categories again, but there's some sort of innate order to them. So like good, fair, or poor, or strongly agree, disagree, strongly disagree. Something like that where there's some sort of order or rank to the categories. Interval data have an equal distance between each value. So think about ordinal. We don't know if the difference between someone rating something as good and fair is the same as the difference between someone ranking someone as fair and poor. But in interval ratio data, like let's say degrees Celsius, we know that the difference between 30 and 35 degrees Celsius is the same as the difference between 40 and 45 degrees Celsius. And then ratio data has all the same attributes as interval level data, but it also has an absolute 0. So there's a place where there's an absolute lack of the attribute, and there's no negative values in ratio data. So an example would be length in centimeters. You could have 0 centimeters, something with no length, but you really can't have a negative centimeters. interval and ratio can get a little bit difficult to distinguish between. And you use the same statistical tests for interval and ratio level data. So I'm not going to have you worry at all about being able to distinguish between interval and ratio, but you want to be able to say whether something's nominal, ordinal, or interval ratio kind of as one. Another really important thing to understand is that variables aren't innately one of these levels of measurement. It depends on how they're measured in the study. So let's think of, as an example, weight. Weight could be an interval ratio level data. We could measure exactly how much they weigh on a scale and write that number down. So somebody is 70.1 kilograms and someone else is 82.3 kilograms. So it could be collected on the interval ratio level. You also could decide to collect weight instead on an ordinal level data. Let's say that you weighed people and then you checked a box of which weight they fell into. So you could either be a less than 50 kilo person, a 50 to 80 kilo person, or a greater than 80 kilo person. If instead of writing the exact number, you just check one of those boxes, now weight was collected as an ordinal level data in that study. So hopefully that makes sense, that you don't just say age is always interval ratio, weight is always interval ratio. You really have to look at how it was collected in the study and determine what level they collected it at.